Okay, so today, just so you know, your notes are going to be nothing but definitions. All right, might be a good idea to get the whole definition that I give you and some examples. Please know that we are going to talk about all of these and work with all of these in class tomorrow. So the first thing is a set. We're not going to talk too much about it tomorrow, but we will be talking about it in a couple of lessons. It's a collection of objects. So for what we're talking about now, I'm going to be sharing with you real numbers. And a subset are all of the categories in a set that are made up of elements. So basically I'm going to show you all the subsets. I'm going to show you all the different categories of real numbers. So the first are your counting numbers, and you need to think about when you were a little kid, or if any of you guys have a little brother or sister, maybe a cousin. When they count, when you say, hey, can you count to 10, what number do they start with? They start with 1. Those are natural, all right? We see that on our fingers, 1, 2, 3, 4, 5, and all the way up. So the next type of numbers, the next category, are whole numbers. Now these are your non-negative integers. These are the counting numbers, the ones that you learn as a small child. And then finally you realize that there's 0. Oh hey, I can make 0 with my hand. All right? You start to understand the concept of nothing. So these are your whole numbers. Then you have your integers. Integers are your whole numbers. So 0, 1, 2, 3, and their opposites. So it's your positive and your negative whole numbers, plus you have 0. So you can look at your that nice little graphic down below. You see where the natural numbers are, you see the whole numbers include 0, and now your integers include those plus the negative 1, 2, 3, 4, and so on. Then we have rational numbers. Now, rational numbers can be written as a fraction, 1/2, 3/4, 7/8, and it's terminating. That means that it ends, all right, so 0.75, done, no more. Or repeating decimals, 0.33333333, and it goes on forever. Or 0.45454545. There's some kind of repeat, there's some kind of repetition there. And this also includes all integers, so not only is it positive, but it's also negative. And then you have your irrational numbers. Irrational numbers cannot be written as a fraction. The decimal does not terminate, again that means end, and the decimal does not repeat. So you can see common ones are pi, all right, 3.141592, and that goes on forever and ever. There is no end. We're going to look at the square root of 2. If you look, that doesn't end, there's no pattern. Those are irrational numbers, never ends, and there's no patterns. Now, real numbers is everything that I just mentioned. It consists of rational numbers and irrational numbers. Please note, we're going to talk about this tomorrow. The irrational numbers are its separate own category. Yes, it's a part of the real numbers, but a rational number is not something like the number 7 or -4, all right? And then an inequality simply compares numbers that are not equal. Less than, greater than, less than or equal to, or greater than or equal to. So those are all the inequalities. So we are going to look at classifying these numbers, playing around with the groupings, and so forth tomorrow.